We are at agentic speed, AI speed. 1 week is 1 month, 1 month is 1 year. I've been to talks with Anthropic. My agent is not a server. My agent is a colleague. So the bottleneck is not intelligent anymore. I think what is a worthy goal is to go through this new period of enlightenment.
It's the 16th episode of Tomorrow's Medicine, and today I'm talking to the person who invented the term agentic genomics. It is Dr. Manuel Corpas. He is the founder of ClawBio and the person on the front line of agentic engineering in biotechnology and bioinformatics. I would not pause any further, and let's proceed to our conversation. Could you outline to us how you started and what were bioinformatics field like when you were in college?
Oh my God. It makes me feel very old now. So it was 2000 when I started doing bioinformatics. So I finished my MSc and my undergrad in biology, and I really wanted to go into computer science. So I found at the time an MSc in bioinformatics from the University of Westminster here in the UK that basically combined, it was perfect because, on the one hand, I would make use of my biology background, but then I would get into the more sort of computational side of things. So year 2000, it was right in the middle of the Human Genome Project. And there was a clear acceleration and a sort of revolutionizing of how biology was being carried out. It was the transition between the moment when it was mostly lab-based, where you would use, you perform your analysis in one gene, into then the more high throughput, where now you start talking about many genes, even the whole sort of genome. And so that was the time when really biology started to become a data-rich, data-intensive science. And so I then continued doing a PhD. And so my PhD was part of what is now called a database called Interpro. So you may or may not have heard, it's one of the European Mathematics Institute databases whose objective is to basically classify protein sequences according to their motifs, to their domains. And so by looking at how the conservation of these specific features are across the whole spectrum of existing sequences developed, then you can evolutionarily classify them. So at that point was already when I started getting into machine learning, artificial intelligence, support vector machines. So technologies which now have been superseded dramatically with the development of neural network neural networks were already developed then, but then when they really exploded was around 2009 when we started with the backpropagation algorithm and the deep networks, which allowed the abstraction of much more complex concepts into the mathematics of neural networks. So after my PhD, I was hired by the Wellcome Sanger Institute, which is the flagship genomics institute on this side of the Atlantic. And I was employed to develop a database called Decipher, whose objective was the analysis of patients with rare genomics diseases worldwide. So Decipher still exists. I think now might have like around, I don't know, last time I looked a year ago was like 60,000 patients with rare genomic disorders, wow, who have been consented for public research. And this infrastructure and this postdoc work sort of changed my focus from the protein sequences into genomics. So I've been doing genomics since 2008. And at that time, I was quite piqued about the fact that it was incredibly difficult, even for clinicians who had been worked at that time with this kind of data, to really help them understand all of the intricacies around the interpretation of data coming from their patient's genome. It was also the time when sequencing started to become accessible. And in fact, in 2010, I actually sequenced my whole exome. So I was one of the first people who sequenced their genome. And that led to the sequencing of the genomes of my family, which then we published online. Many people thought it was crazy, but we just decided to sort of put it outside in the public domain so that anyone and everyone who wanted to use those data for the development of tools or simply for research purposes. And I gave the condition that, anyone can use it, but if you want it, I'd be very happy if you found any kind of results about my family, which could help us inform the understanding and really push the boundaries in terms of how much your genome can tell about, future life decisions and life choices. And since that time, I've already been obsessed with that same question, which is understanding how the genome can help inform life decisions for a better quality of life. And I don't think really we have made a lot of progress. Technologically speaking, obviously, we have more data, but this data, again, has always been not widely accessible because patient data is incredibly sensitive, is incredibly expensive. And so we haven't had the same sort of chat GPT moment that, artificial intelligence has had because, you had Wikipedia, you had all of the internet. I think that's precisely one of the main bottlenecks in terms of medicine of the future. The fact that we don't have enough data or at the levels required to be able to sort of generate the sufficient training that would be required for sophisticated models to be able to really represent the richness of biological complexity. I'm hoping that this may change in the near future as more data and more biobanks are made accessible for research. But it's not, the fact that clinical data, medical data is so unique, so sensitive, is already a big barrier that is sort of, hampering the fast advance that we have seen in other fields such as, fintech or law or, even crypto. Everyone, I felt when I started getting into agentic genomics, which was, like last year, it was sort of colonized by crypto people. So anyway, I've been a senior lecturer in genomics for about 5 years now at the University of Westminster here in London, and that has really conditioned my exposure to being really, up to date in terms of the AI developments. I think London is really a thriving place for AI. There's always something happening. So I've had, and it also has a critical mass, with many universities, many research institutes, Google DeepMind is here, and many other startups. So that has really conditioned where I am today.
And you was working on Decipher before this agentic boom in AI, and you are now the person on the frontier of agentic science. How do you think if these years ago you had the tools that you have now, would it speed up the process consistently?
Yeah, but the thing is that I don't think there's a real understanding of the type of usages that agentic capabilities are able to provide. And so right now I feel like in heaven. I'm really, I have all these data sets that I've been accumulating for a long time, but like the ones from my own family and so on, which was quite rich in terms of the amount of data that we had, all of the other projects that I've been working on. But I don't think most people who are doing genomics really have a deep grasp of the where this can take us. And so I've been frantic, especially since the beginning of, now I would say since I guess for the past 2-3 years, I knew. So one of the things I can say is that I started a program on AI and digital health at my own university, directing a master's degree on that subject, and so that together with my fellowship at the Alan Turing Institute, which is the national capability sort of institution for AI here in the UK. So that sort of helped me get up to speed in terms of making sure that I wasn't just going to be a passenger. I mean, I knew I was going to drive the process forward. I really want to, particularly on my domain expertise, which is the application of these technologies, particularly around the genomics and health equity aspects. And so I would say, the thing is that to be honest, for me, what was really changing, apart from the fact that I have the capacity to develop things at a speed which is maybe 10 times faster than it was before, I've sort of have built probably an army of agents around me that they help me with the automation of the many tasks that I've been sort of confronted on a daily basis. And so for me, making sure that I kept up to speed hasn't mean that I actually kept with what the developments have been for the field, because I mean every week there's a new model, there's a new harness, there's a new tool, and it's absolutely impossible. And I think everyone feels that way. And in a way, that sort of being on my own is what actually motivated the development of ClawBio, which is the open source biodomain library of skills for agentic AI. And what a lot of people don't see about what I've been doing is that it's not actually as much as, I mean, of course, it is about the technical developments and the capacity and the capabilities and the fact that, we have a set of tools which and a platform that, potentially is useful for many people. But I think it's also this community aspect, the fact that I can't keep up to date with everything. But if we have now a community of people who are experts, who care about, how the sort of agentic revolution is going to be invented and developed moving forwards within the bioinformatics / omics realm, that's the best possible way of really surviving the tsunami we are all in.
And I feel it's, first of all, thank you for the comprehensive overview. And I feel it's a great moment to clarify the terms, because maybe someone in the audience is not familiar. How would you describe agentic genomics? People probably understand for now what agentic means, and some people understand what genomics means. I'm sure not all. And what are this combination of words, in your opinion, should convey to people? And what is the second sub-question? When was this time, this light bubble, when you understood that agentic genomics might be a thing and you started pursuing it?
So agentic genomics is the use of autonomous AI agents powered by a large language model and operating within a domain-constrained skill library so that they can discover, plan, execute, and iteratively refine multi-step genomic analysis, where the agent exercises runtime decision-making over tool selection, parameterization, and error handling, as well as output evaluation. So that would be the sort of formal definition. But if I put it in simpler terms, is this idea that a harness that you may have, Claude Code or a Codex or any of the current sort of layers on top of the LLM that allows you to autonomously and sort of in using natural language typing English basically on the command line. It's going to be able to interpret your intent. And it's going to basically solve a task without you having to actually do any of the programming. That's really what this is. If I was to put it in a simpler term, even sometimes it's a little bit like Alexa or Siri, right? It's you tell something to the robot in English, and then it does something and comes back to you. Except that Alexa is kind of poor because it's only it's just one back and forth, whereas the agent loops itself. So it's going to decompose your intent into a number of tasks that is able to sort of ascertain based on the context and the training that it has. And then it can execute complex workflows in an automated way. It can sort of trace back its steps if there's an error. And so it can do a lot of the things that a developer could do before, but now in an automated way.
And when was the time that you understood that it's possible that current LLMs are on the level to fulfill the tasks you need? Was it after GPT was released?
No, it happened really when I got into Claude Code, which was last Christmas.
A year ago, okay.
Having a number of inflection points. The last one was really last Christmas, when suddenly, and it wasn't just me, I think it was for many of the top leading AI voices, where there was a little bit of time, holiday time, and then people started tinkering about this thing that allowed it to sort of work with powerful models. So you had to have the what we call the harness, which is the layer on top that goes on the LLM, which allows the sort of loop aspects and then the sort of internal mechanisms for the robot to act in a series of workflow actions. So you needed to have the harness. In this case, it could be Claude Code. But then you also needed to have the model to be powerful enough to allow the sort of reasoning behind for it to happen, so that it could execute these complex tasks and understand the intent in a sophisticated way. And that's only happened. The earliest people who would have worked on that would have been around November, which was in this case, for instance, I can think of Peter Steinberger, who developed, I think it was called Claude. He had a number of names, and it ended up being as OpenClaw, which was it was basically the pipeline to help you interact with the LLM through different channels. So you could now then talk to your agent via Telegram, via WhatsApp, and so suddenly it became something that you could be running 24/7, and it would, you could add its own soul, so it would have its own personality. And so at that point, especially from November, December, January, that was when, in my opinion, when we've had the last sort of big inflection point. And that was when Anthropic stopped being a sort of underdog, and then suddenly that everyone then realized, wow, Opus, the things it can do, and it can do it automatically, and it's going to do this super complex reasoning. So that was the time when, and it's kind of really incredible. I mean, it's not even having a year and it's transformed the way I work, and it's going to it's transforming the way any digital work is happening. And it was very clear by then that this thing, could and should be applied to bio. And so I presented this for the first time in late February. I presented ClawBio as a library for reusable skills. And by skills, I mean like self-contained context that agents can discover and reuse for performing these automated tasks. So I presented it at the end of Feb at the London Bioinformatics meetup. And I was absolutely surprised because, the London Bioinformatics meetup has people from the top scene in the UK, in London. You have people from the top pharmaceutical companies, from the top universities, global leaders. And nobody knew what Claude Code was.
Wow.
And it was like, oh my God, I'm on my own here. And so at that point, then the next week, I joined the AI Agent Hackathon, Agentic AI at Imperial College London. So it's the biggest hackathon on Agentic AI in Europe. And then I presented ClawBio. Yeah, there were hundreds of groups for the hack. I presented Claude, and it won the gold medal. It actually won the hackathon. I've never won anything in my life. And I thought, wow, I'm onto something. And since then, the growth of ClawBio has been exponential. And I get these people now contacting me from, I don't even know who they are. I get all of these people contributing code because there's nothing like that. I think that the main sort of advantage that ClawBio has is that although I'm sure there are other companies who are doing agentic stuff, there's nothing open source. And so here we are, I somehow, I'm this unlikely person who somehow seemed to be, a couple of months ahead of where the curve would start inflecting. And that's what's being, maybe I'm not saying that I might be that way in a few months, but I can tell you that I've been to talks with Anthropic and with other big frontier labs. And definitely what we are doing right now in terms of agentic genomics is definitely is certainly a few months ahead of what they are talking. Maybe they might be talking internally, but publicly, I believe that this is ahead of the game right now. And so for me, I need to capitalize on this moment because, we are at agentic speed, AI speed. 1 week is 1 month, 1 month is 1 year. And so I've been trying to cope somehow with this new way of doing things. And I think today has been a culmination with this first paper ever on a top journal on agentic genomics. So I think, and I'm hoping that this new paper will be defining for the field.
I think that 1 week is 10 years now. I'm a computer scientist by training, and the stuff that I can achieve now is just mind-blowing. And speaking about why you were on this wave, I think it's a combination of the right skills, because you were working in genomics. It's not that you learn genomics in 1 week. And the second, that you were in the right places, you said. I know London, it's a great hub where many science and biotech projects are happening. And I'm just grateful that agentic genomics is existent, because I know that many bioinformaticians were crazy about routine tasks that they should perform. And many even top people were doing some stuff that is probably automated, by Indian freelancer, and they were doing it. And right now we can off this load to the agents. My next question for you is, why does it matter? why does genomics matter? We can pose even these questions. What scientific research done with the help of agentic genomicists and these systems can bring to the world? It's a deep question, actually.
No, I think what I always say is that, and what my own personal strategy, I don't have to actually. The questions are the same. What's changing is how you do it, and I always say that the way to get into this and is not by trying to find new problems. You're already working with the problems. It's just that now the thing is, how do you do what you were doing before, but now in an agentic way? And that's what I've been doing again and again. And, first I started with pharmacogenomics. So because pharmacogenomics is a easy tractable problem. So you have a mutation, you're going to have a phenotype. Full stop. So you don't have that, then you have that. But there's a black or white, and an easy way to validate it, because you have the CPIC guidelines, which is an international society for pharmacogenomics that tells you very clear criteria. And so those are the low hanging fruit where you already know what the correct answer is. And so then if you test your particular problem, then you can easily know whether the agent workflow has worked correctly or not, because you can benchmark it. But where the real sort of challenge is when there are no sort of clear benchmarks. Say, for instance, variant calling, or even I mean, there's a benchmark for variant calling using, for instance, genomes in a bottle, but it's not. It's kind of not very. Just you have very few genomes. Anyway, more on the interpretation aspect. You are trying to sort of interpret the actual effects of any given variant. It's not a black and white answer, and it's very convoluted, the type of criteria that there are, and so on. And it's very difficult to really have a sort of publicly and openly accessible standard gold truth, which then you can benchmark against. So I think that's the sort of where the future is going to go. So and it's going to be jagged. So for some things, agents are going to do really well, particularly if you have well benchmarked, well standards of truth. For those part of the genomic world or omics or bio work where it's not sort of clear what the right answer is, that's where there's going to be a lot less development. So I think, and of course this is a new way of thinking, and so the level of specificity that is required for this incredibly heterogeneous and the diverse set of skills required for any kind of bioinformatics pipeline is never going to be captured in any of the generalist models. They'll be really great for reasoning, but when you get into the real deep sort of expertise domain, that's never going to be captured, and that's where I see the opportunity, and where I think that we are right now at the right time for people to be able to join and to hopefully build on those very sort of specific, thin but deep expertise.
And how many people are working on ClawBio right now, and how many people are using ClawBio? Can we get some numbers?
Yeah, so I mean, it's completely open source. It costs me money. I mean, I think right now, by my last count, there have been 43 people who have contributed code. Mm-hmm. And it's been downloaded around, cloned, should I say, around 5,000 times a week.
Oh, wow. It's a great number. Actually,
considering that it started in March, really, when I made it public. So it's only been like 4 months. it's again, it's agentic speed and exponential growth.
Was it growth right from the start when you published?
Sorry?
Was this type of growth the same right when you published, or was there like a plateau?
No, there has, it's been a little bit like ups and downs, and it follows, if I am giving a big hackathon, or, if I put something on LinkedIn that suddenly goes viral, I wrote this book on agentic genomics.
I've seen it.
And then suddenly, so it has some peaks, but, I found quite stable. So it's always around 4,000 to 5,000, sort of downloads. And, I've never built anything like that before.
And you said you were inspired by OpenClaw founder, and I've seen on the LinkedIn, I believe, that you met him at some presentation at Imperial that he did. Did he give you some advice, and
no,
was it some interaction?
He was too famous and busy. So he was, Peter Steinberger was, he was based in Vienna and London, somewhere in between. Now he's also a lot of the time in San Francisco because he's working for OpenAI.
OpenAI, yeah.
But I've been at a number of events where he's been around, and I've been listening to him, but I've never had a proper conversation with him. But, he was around and said, "Oh, Peter, can I have a picture with you?"
It's like me attending some Bitcoin conference.
Yeah.
So this agentic speed, and it brings us to the second part that I wanted to talk about, which is the wrong scaling. Because right now, agents are scaling anything that people do, and health, bioinformatics, genomics data is very inequitable. It's a huge topic on your research that about 86% of data is with European ancestry. And then my kind of next thought that these agent systems even exacerbate such an inequity. How can we deal with it? And what are the biases that you're currently seeing?
So agents and AI in general, so they amplify everything.
Yeah.
So it starts from a base which you have to imagine, and this is something, it goes a lot deeper than the actual data that we are dealing with. If you think about the scientific enterprise, in the past, let's say since the Industrial Revolution, where has it really happened? Until very recently, it's been Europe and US. And so there is this traction that has gone for decades, even centuries, where the people start, what are the best known diseases? Well, the diseases that affect the global West. What are the sort of best understanding of the biological mechanisms were around the things that have, where most of the funding, most of the energy, most of the companies, the industry have been developed. And so this is incredibly entrenched in all the biomedical enterprise. And this is something that I don't think it has been properly put across. I have a number of figures. You think about, for instance, clinical trials. There's around, in the clinicaltrials.gov, there's around 500,000 clinical trials. And you basically then compare the number of clinical trials associated to a specific disease. And then you classify them whether these diseases are predominantly from the global north or the global south. And the disparity is breathtaking. Then if you look at even just the sheer scientific literature that is the body of knowledge, you can look at something called PubMed, which contains all of the biomedical research that have been published since the 50s or something. And again, the body of knowledge is incredibly well developed for things that are from these particular countries. And then the further you go from those countries, then you have diseases like, I don't know, leishmaniasis or even malaria, and until very recently COVID, where basically the connection between the language that is being used in those publications for type 2 diabetes, for sort of industrialized nations diseases, this is incredibly well connected. And so you have this sort of situation where, let's say, you develop something for COVID, and then anything around topics that would be related to COVID, such as, for instance, immunology, or let's say DNA recombination, whatever, they get, there's quite a lot of spread. The things that have been developed for type 2 diabetes or for heart disease, it can be easily spread to other diseases of the Western world. And then you analyze the language of diseases that are affecting the global south, such as, for instance, parasite diseases. And you find that the language is quite disconnected. There's not so much overlap. And so, these are part of my research where basically demonstrated that in semantic space, even the way knowledge is being produced, there are severe disconnections, whereas the diseases are already well known. They get most of the attention, most of the clinical trials, most of the publications, and they keep developing, and many of the diseases that affect 1.5 billion people, they're still the same sort of level as they were a couple of decades ago. So this level of granularity in which we are able to sort of identify how knowledge is being produced hasn't been properly analyzed. And that by definition, which is the sort of body of data from which AI is then built, then it's completely amplified, because that's what AI does. AI amplifies everything. And so the way to really fix that is that health equity has to be architected from the design itself. You cannot really expect that by doing more research on a particular sort of neglected disease, you're necessarily going to sort of have all of the impact that you could have. There's a lot more structural type of ways in which research is done, which is mostly driven by financial sort of needs. Of course, we live in a capitalist world, and you have to have return for investment. But what we are not aware is the sort of this cycle of negative reinforcement, where the actual neglect, sort of, you have a cascade of neglect that keeps sort of making those diseases that affect the poor global south still not advancing at the same level. And I have data where you can see if you have diseases that are well connected in the knowledge space, the degree of hallucination is a lot smaller than diseases that are not so well represented. And in fact, we show that we can predict we benchmark it with 10 models, 9 models, Gemini, Claude Opus, Claude Sonnet, GPT 5.4, and some others. And they all independently have a similar amount of hallucination that correlates inversely with the knowledge representation for those diseases, especially of the global south. So, and then what we also find is that you can encode a lot of those inequities in the skills, and if you're able to sort of architect and design and know specifically that you encode these differences that are specific for those diseases by design in the skill that then agents are going to be exposed to, then you have a tremendous guardrail and we find that those differences that we find, especially in different populations, from Europeans into Africans or Asians, we see that those differences that you sometimes find due to the ancestral ethnic background, they disappear if you are able to encode them by design as part of the sort of skills and the design of the context that you give the agents. So I think there's room of hope. We have, on the one hand, better ways and better tools with which you can analyze and understand the structural inequities. And we can understand that from angles that were not possible before. But then at the same time, we know that if we are able to pick what those gaps are, there are ways in which you can use those sort of strengths that AI has for amplifying into then closing that gap.
Do you think LLMs and these big AI companies would on itself be able to fix this health equity problem? For example, when training the models, we can use the same models to evaluate the strength of evidence and understand the statistical distributions and understand that probably information is misrepresented? Or would it be necessary for real people to take part in it? What's your sense on that?
I think they're going to be in the same situation as we are. So unless you identified where the gaps are, we are completely blind. I think
people should identify where the gaps are.
Researchers. People like myself and Festival we have a set of tools now which give us an amount of capability that didn't exist before. And we can use those new capabilities specifically for the purpose of identifying health inequities. And this is what I've been doing now for, 5 years, 6 years. And it's incredible. You are able to find new sources of inequities that we were not even aware of before. And so then by identifying those gaps, then you can leverage the power of LLMs to hopefully engineer capabilities that will help us make those skills aware of those gaps and therefore at least close the gap. Now, you cannot expect that the companies are necessarily, the frontier labs are necessarily going to address this. I know that Anthropic just launched this sort of rare diseases challenge, but there are very specific use cases. And I think they are playing with the same data that is available to all. And so the thing is that if you have biased data, then you're going to have biased models. And so there's no way around it unless you have a very specific targeted way where you can really, not just the models, but the way you apply those models, make them aware of the specific gaps and hopefully close the gap.
Okay. And you have a ever-growing community for ClawBio. You see some ideas that people suggest. You have ideas on your own. What are 3 main threads that you see this product evolving, and what are you working on right now?
I'm just going to give you just one. So I've said it already in some other conversations. Having skills and having a diversity of different sort of capabilities that could then be reusable by the community is great. But I think where the bottleneck is in having a set of robust skills that you can trust. So this sort of trustworthiness / validation aspect of, can you really use this? Let's say imagine that you're a hospital or you are a pharmaceutical company, the stakes are huge. So how can we really be in a situation where we feel confident that this agentic thing are going to perform in a way where the error or the hallucination is not 99%, correct. 99% correct in the clinical aspect, in the clinical realm, is inadmissible. You cannot have that. You need to have a millionth of a percent error for it to be clinically applicable, and many orders of magnitude even than the current established standard. Because when you're introducing a new technology, you don't expect that technology to be as good as it was before. You expect it to have 3-4 orders of magnitude better accuracy. So understanding how we can trust those agentic enabled workflows, understanding not only whether they are accurate, but understanding the different breakdown checkpoints, because accuracy, you can have an accuracy, and that accuracy you've achieved through a number of routes. If I think, for instance, of genome interpretation, so you want to classify a particular genetic variant, whether it's pathogenic or not. So a benign variant, a variant that doesn't do anything, you can reach that route through many different paths. Or a variant of uncertain significance, you don't know whether it's uncertain because you lack evidence, or because there's not enough ingredients for it to be clear, or maybe something failed. So it's not just about understanding the accuracy itself. It's about having the granularity of all the different components that then give you the final number of accuracy. So that decomposition of how you arrive to the specific result, in a way, not just that is validated, but also auditable, traceable, reproducible, and it can be inherited. That's where I think the real future is, and that's where I'm going to spend my energy for a long time moving forward.
Do you think it would be a long time? What's your time scale for reaching some, maybe not the grand milestone, but the closer milestones? Is it a few months in which...
Next month. Well, talking about agentic care, it has to be next month. Next month, I will have something. I'm not saying I'm going to solve all of the problems, but again, I think it's this question of picking, and this is where the real strategic thinking comes. It's the number of problems you can work with is incredibly diverse. So pick the problem where, most of the people in genomics, they're interested in, i.e. variant interpretation. Everyone wants to do variant interpretation. Hospitals, researchers, and it's a hard problem. So that's the problem I pick. And that's the problem where I'm hoping to have a solution the next month.
Great. In 2026, it may be a personal question, but do you run your agents 24/7? Which codes, ClawBio and so on?
Yes, and I've had a number of surprises. I'm completely broke.
That the pipeline broke something, you mean?
No, I think poor. I've spent a huge amount of my money.
Okay. I see.
For instance, I ran out of subscription credits. I did the other day. So I had an agent working for about 3 days nonstop, and then I thought it was going to do something really great, and then I had to discard it completely. But then, it's part of the game. I had to be, and this is why I guess part of my secret ingredient for being successful in this. I was very quick to spend my dollars, get the subscriptions, I wasted. I spent a lot of money, in credits, trying this, trying that. And I already have assumed that, maybe 80% of all the money I spend is going to go to nothing. But then I get all this experience. Then I start understanding how the different harnesses work, how the different models charge, sometimes I was spending like $60 a day just on all of these things, and I had to stop. Sometimes I've had the situation where I had agents spiraling, and suddenly I see like £500 going out of my account. So it was having to stop everything quickly. And it's all experience. And I think the fact that I've been able to spend that amount of money, and
I was about to tell you, in finance, we have time value of money. Dollar tomorrow is valued more than, no, dollar today is valued more than the dollar tomorrow. And in AI agents, it's completely reversed. Like what impact $20 Claude subscription gave you a year ago is incompatible with this $20 that it is giving you right now. And it's crazy. So I got token conscious, if we can say so, and I'm truly thinking maybe when Fable came out, I'll test it. And I've postponed even some of my projects to wait for the newer model to allocate intelligence better, because when I started using Claude Code, it was also a year ago, similar to yours experience. Let's be honest, it was so much dumber and it couldn't do many things, and I've lost also pretty much of credits on it. And yeah, it's just weird paradox in AI that you have not increasing value in time, but decreasing.
Yeah, it's many of the paradoxes that we are now confronted
living in.
So, but if you want to be 6 standard deviations ahead of the curve in terms of adoption, you're going to have to spend your money, you're going to have to spend your time.
100%. And I'm seeing that you're building a media presence. Is it your intent to just get more people to know agentic genomics and your project ClawBio, or were you doing it before you started working on it? What's your stance on media presence? I'm personally interested because I'm also trying to put my work out on the internet, and just love to hear your story.
So I think my goal is to be the person who defines how agentic genomic interpretation gets trusted. And I guess unless you really are able to ship products, things that add value, you're out. And so I used to be one of those who, again, in the social media years, I had my blog. I had one of the first bloggers in my field. I also have my YouTube channel. I have to be on everything. Then I've come to realize that now I don't care so much to just have mere presence, or put pictures or say, oh, look, I attended this, I attended that. Now I am more of someone who says, here is something, here's a powerful deliverable, like this article, here is this tool, or here is this new cool functionality that I've been able to do that wasn't possible before. So I've changed a lot in terms of how I publish things. So I just don't put things that say, oh, hey, I'm showing off this particular, oh, I'm here, or look, I'm so famous, or I'm more of someone who pushes things when I have something important, to some learning or some value, contribution that I have to share the world. And because I'm completely agentified now, so every week I have something big to say. You know, I've published this book, or I've published this article, or I've published this, or I'm organizing this event, or so, and that somehow retrofit itself into a community where, you know, especially my LinkedIn account has been exploded since in the past few months, you know, you know, I get, I don't know how many new contacts every day in my, as followers. So that has happened before. And so I guess it's like, it kind of fits itself. And then when you get your particular name, your particular brand, your particular niche, then people are really interested, especially if you're producing things that people perceive value.
And now we're at the place when we can put all things together. Bioinformatics went from this wet lab science and basic computer programming to big data, to this boom of databases, huge data sets, huge computation, into now self-sufficient, maybe in the future full agentic system. And our challenge is to make sure that it provides necessary health equity, that it is validatable, then it is trustworthy. And we're about to speak on the topic of my show, which is Tomorrow's Medicine, and bringing this all together, bringing your work on agentic genomics. What do you think will happen in a decade, in 10 years? And what do you want to happen to our medical and health system? How do you think this would practically change, not only scientifically, but practically change how medicine practitioners, providers, clients, patients interact, and do you see a bright future or a great one for our healthcare system?
I see a great future as long as there are some of us who fight for the truth. And I see a future where capability and knowledge is democratized. So the bottleneck is not intelligence anymore, is your ability to ask questions. I see a future where you do your research in conjunction with the AI agent as a partner, or, you know, which I'm already doing that anyways. So it's not, my agent is not a servant. My agent is a colleague. I keep asking things. We go back and forth. And so you have this sort of symbiosis between the human point of view, which has this sort of nuance of the real world that I don't think that AI will ever capture. AI will be able to sort of mimetize, you know, mimic human intelligence and go much beyond, you know, the processing that is able to hold, you know, a billion token context windows and things like that. So they'll be able to do a huge amount of thinking that we will not be able to do. But how we apply that to the human reality, to the things that humans really care, as a way to sort of develop us, not as servants, but as sort of enhanced, enlightened beings. That's where I want it to go, and I want it to be something which is not used as a weapon by institutions, by governments, something that is able to reduce the barriers and allow us to do things that were unthinkable before. And I'm already doing things that were unthinkable before. in terms of my outputs, in terms of the kind of thinking that I can do. I don't have to worry about the math so much, about what algorithm to pick or choose. I know that AI is going to help me choose the best optimal algorithm for this particular task. But what it doesn't know is, what I really care about. So they'll be able to be very empathetic, but I still think that the sort of human relationship aspects and the sort of physicality that we are able to have, the experience, the organic side of things, they will never be able to sort of reproduce. And so I'm not interested in superintelligence. I think that's it excludes. And what happens if you have Down syndrome or people who have disabilities? I don't think superintelligence is a worthy goal. I don't think that superabundance is a worthy goal. I think it's selfish. I think what is a worthy goal is to go through this new period of enlightenment, super enlightenment, where we're able to achieve a new growth and understanding that makes us more human, that makes us more complete, that is able to help us understand our nature, our physical nature, our spiritual nature, our emotional nature better than ever before. And that's the goal I want, and that's the goal I'm going to fight for.
Thank you very much, Dr. Corpas, for appearing. It was a nice episode. I took a lot from it, and it was great to talk to the person who is on the frontier. We'll definitely follow you, what's the future of ClawBio, what are its developments. And once again, thank you for participating.
My pleasure.
Everyone, it was 16th episode of Tomorrow's Medicine. You know what to do. Subscribe to Dr. Corpas, subscribe to myself, leave a comment, share with your friends, and see you next time.